Hello everybody, myself Prashant Mukhopadhyay, faculty member, Electrical Engineering Department, Greater Kolkata College of Engineering and Management. So in our last class, we have started with the starting methods of three-phase induction motor, and where we have discussed the dual starter, its working, its advantages, its disadvantages, etc. Today we'll discuss about the other say starting methodology of induction motors. So let us start with our discussions, that is with for starting methods used for three-phase squirrel cage induction motor. Basically, there are three methods we are using. One is primary resistors, or you can say reactors or rheostats, or a starter resistance starter. Secondly, we use auto transformer or auto starter, and thirdly, the most important one, the star delta starters. And for slip ring motors, we generally use rotor rheostat or rotor resistance starter. Okay, so for squirrel case, that is primary resistor or starter resistance starter, or primary reactors or rheostat starter. Secondly, auto transformer starting, and third is star delta starter. And for slip ring motors, it is rotor resistance or rotor rheostat starter. So there is a basic difference between these two resistor starter. That is primary resistor. That is primary means it is the starter resistance starter, and here it is rotor resistance starter for slip ring motors. Okay. Let us start with primary resistors. See, this is the say circuit diagram of a primary resistor starter for squirrel cage induction motor. So actually, what is the purpose of using this primary resistors or starter resistors? Basically, our main objective is to reduce the high starting current. And I told you during our discussions that the high starting current can only be reduced by supplying reduced voltage to the motor terminals, that is the starter winding terminals. So in order to apply this reduced voltage to the starter of the induction motor, the three resistors are added in series with each phase of the starter winding. So these are the series windings connected with this phase. This is connected with this phase, and this one is connected with this phase. If it is A, B, C, so these are connected in series with the starter winding. Okay, and initially the resistance are kept in the maximum. That is, the start positions of total resistance will be inserted in the windings, respectively, and as a result, the required voltage drop will happen in this say starting resistance across the starting resistance, and here as a result the reduced voltage will be impressed in the starter winding. Okay, and gradually this rheostat will be resistance will be decreased, and finally it will be cut off to get the full voltage say applied across the starter winding. So hence a reduced voltage gets applied to the starter, which reduces the high starting current. And this is the schematic diagram of this starter resistance circuits. So this is starter, this is the squirrel cage rotors. As I told you, this is three-phase supply, and this three-phase supply is being this say switch is connected. So voltage will be say placed like this. So this is like this. Okay, clear. So initially this power point, if it is here, so the total say resistance will impressed connected in series with the winding, starter winding. So that will be like this. If it is here starting, okay, so it will be like this. Clear? It will impressed like this. Okay. Similarly, actually, in this way. Okay. And actually, when the motor starts running, so these resistance are gradually cut off from the starter circuit, and finally the full voltage will be impressed across the stator winding. So when the resistances are entirely removed from the stator circuit, that is just as in LAN position actually, then a rated voltage gets applied to the stator and motor runs at normal speed. So actually, see, this is stator winding and this is the rotor, squirrel cage rotor. Okay, and this is the stator resistors or resistors, you can say. This is the three-phase stator winding of the induction motor. This is the three-phase supply, and this is the main supply, main switch. Okay, so the stator is very simple in construction and it is cheap. It can be used for both star and delta connected stator, and large power losses due to this resistance definitely will happen. And the starting torque of the motor reduces due to reduced voltage applied to the stator at starting. Okay, if we discuss about its operation, so it is, you see, the rotor input power at synchronous speed, that is air gap power, will be omega times the torque produced. Omega is the angular frequency, and so therefore we can write this torque is directly proportional to the rotor power input, that is P2. But we know, we have already seen, that is this P2 is related with PC by S, where PC is the total copper loss. In the three phases it will be 3I2R square R2, okay, and divided by S. This S is the slip. So if these are the constants, so you C and R2, and so we can write the torque is proportional to directly I2R square divided by S. So actually, therefore, torque is proportional. It is a stator current square divided by S is the stator current. So at starting S equal to unity, and torque will be the starting torque, and the stator current will be the starting current. So therefore, you can write this starting torque is directly proportional to the starting current square. Now, when stator resistance stator is used, the factor by which the stator voltage reduces is say X, which is X is less than 1. So starting current is proportional to the factor X. So if the normal current drawn under full rated voltage condition at start, then at starting current will be X time the short circuit current. So this is the full rated current at starting, and therefore the starting torque should be equal to XISC whole square. Okay. So, but full load torque, we know TFL is directly proportional to IFL square by SF. ISF is the full load slip. So now, if we take the ratio of these two equation 3 and 4, so we can say the ratio of the starting torque and the full load torque will be X square time this ISC plus IFL whole square into SF. Okay. So this is found here. Okay, this method is actually useful for smooth starting of the small machines only. So that's all about the operation of the say stator resistance stator or primary resistor stator. So this is the schematic diagram of the circuit, as I told you. This is the three-phase supply, this is the main switch, this is the stator resistance, this is the stator winding, and this is the squirrel cage rotor. At the beginning, the total resistance of the stator is impressed to the stator winding, and as a result, reduced voltage will be supplied to the stator winding, and hence the starting current will be reduced. And gradually, when the rotor is speeded up, so this stator resistance is cut off, and finally when it is at the wrong position, the total entire resistance which is externally added to the stator winding will be cut off, and the full voltage will be impressed across the stator winding, and the motor will be say run at the rated voltage, and when it is loaded, the full load current will flow, or rated current will flow. So if we, the main advantage of this starter, it is simple in construction and cheap, used both star and delta connected starter. Large power losses due to resistance is happened here. So the starting torque of the motor reduces due to the reduced voltage applied to the stator, and say this can be mathematically be discussed here. This is the rotor input power, that will be this omega time torque produced. So we can write this torque is directly proportional to the rotor power input, and so this is again related with the total copper loss divided by S, so P2 equal to PC by S, and this P is equal to for 3-phase 3I2 R square into R2, this is the rotor resistance, and therefore we can write that T is directly proportional to I2R square by S. But rotor current I2R and the stator current are related to each other to transformer action, as I know. So we can write that torque is proportional to I1 square by S, where I1 is stator current. And at start S equal to 1 and T equal to TST, that is the starting torque, and I1 equal to IST, that is the starting current. So therefore we can write the starting torque is directly proportional to the starting current square. Now when a stator resistance stator is used, the factor by which stator voltage reduces is if we say it is X, which is less than 1, then starting current is proportional to this factor X. So if the normal current drawn under full rated voltage condition at start, then starting current should be equal to X times ISC, and starting torque will be X square ISC square, or X ISC whole square. But full load torque is directly proportional to full load current square divided by full load slip. And so if we take this starting and full load torque ratio, so this will be X square ISC by IFL's whole square into SL. So that is the derivation. So this is this method is useful for smooth starting of small machines only. Okay, so that's all about the primary resistance or reactance starters or stator resistance starter. Okay, for squirrel case motor. So hope it is clear to all of you. So next topic will go for discussions is auto transformer or auto starter or compensator. So before starting this auto transformer starter or compensators or auto starter, so I once again want to tell you that I think this primary resistance starter, as you have understand it, say, and if you don't have understand it, if you have any queries, you go through this lectures and say, and after that you may contact me, as I told you earlier in different times and many times, that in that case you contact me, so that if you have any problem, so we can address that problem, and you can say grasp the subject. So let us start the auto transformer, auto starter compensators. Okay. So actually, three-phase star connected auto transformer can be used to reduce the voltage applied to the stator. So for the same function, basically we have to reduce. Main objective is to reduce the starting current, and we can reduce the starting current by reducing the supply voltage supplied to the stator winding. Clear? So every starter is this is the main objective. So three-phase star connected auto transformer can be used to reduce applied. As I was telling you that the main objective of the starter is to reduce the high starting current, and that can be reduced only by impressing the reduced voltage to the starter winding terminals. So in primary resistance starters, we have seen that the voltage, reduced voltage is applied through the primary resistance, say connected in series with the stator winding in phase. Actually, here also in auto transformer starter, three-phase star connected auto transformer can be used to reduce the voltage applied to the stator, and such a starter is called auto transformer starter because the auto transformer is being used here. And the schematic diagram of the auto transformer starter is shown here. This is the three-phase star connected auto transformer. This is the say double pole say type switch. Actually, see here it is three-phase supply is given. Okay, this is the stator winding and this is the rotor. So actually this switch is called a changeover switch. Basically at starting this will be connected to the say auto transformer start connected, and at running condition it will be change over to the this terminal so that the full voltage can be placed across the stator terminals. So actually this can be when the switch is at start position, the starter winding is supplied with reduced voltage, and this can be controlled by tappings provided with an auto transformer. Actually, there is tapping, different tappings are provided here. So the reduction in applied voltage by fractional percentage tappings, say X, used for an auto transformer. So this is shown here. This is auto transformer. This is stator. Okay, winding of the induction motor. This is the rotor. See, basically when the this is star connected terminals of the auto transformer. This is the supply voltage per phase, root 3 V1. And this is line. Actually, this is line voltage, and this is the per phase voltage. Actually, so these are the different tappings at the auto transformer is connected to the stator winding terminals. When the motor gathers 80% of its normal speed, the changeover switch is thrown into run positions, and due to this, see, this is the changeover switch. So this is right here in the run positions. Okay. So due to this, the rated voltage gets applied to the stator windings, and as a result, the motor starts rotating with normal speed. And changing of the switch is done automatically by using relays. So main objective of this stator, this type of stator, is that the power loss is much less in this type of starting, whereas in case of primary resistance stator, it was power loss is very high. So it can be used for both star and delta connected motors, but it is more expensive than stator resistance and starter. So if we go for the deductions of this circuit, so we find the voltage across the motor phase on direct switching is V by root 3, and starting current is I starting equal to ISC. But with auto transformer starter, the voltage across the motor phase is K V by root 3. Okay, and starting current is the K times the ISC, that is the short circuited current. So as a result, we can say starting torque proportional to IST square. The starting is equal to 1, and full load torque is proportional to IFL square by SFL. That is the full load slip. So if you take the ratio of these two, the starting torque versus the full load torque, you will get the IST by IFL, the full load current torque squared, into SF, that is the full load slip. So if you say that the ratio of the starting torque by the full load torque, it will be if you put the starting current equal to K times ISC, so it will be K square ISC by IFL square into SFL. So this deduction is showing that with the auto transformer, reduced voltage is being impressed initially, and the starting voltage is reduced, and as a result, starting current will also be reduced. And after getting say 80% over speed, changeover is done from start to run conditions, and as the full voltage will be impressed across the starter winding, and as a result, so motor will be say get the full voltage. And main advantage of this type of starter with primary resistance starter is that it is say power loss is less, but it is expensive than starter resistance starter. And this type of auto transformer starter can be used both for star and delta connected motors. Okay, so that's all about this auto transformer starter. Now, if we will talk about the star delta starter. So actually, this is the cheapest starter of all, and hence used very commonly for the induction motors. And it uses triple pole double throw switch. The switch connects the starter winding in a start, and hence power phase voltage gets reduced by a factor 1 by root 3. And due to this reduced voltage, the starting current is limited. But when the switch is shown on the other side, the winding is gets connected in delta, and across the supply actually, so it gets normal rated voltage, and the windings are connected in delta when the motor gathers sufficient speed. And the arrangement of starter also shown here actually. So the advantage of this type of starter is this is cheapest of all type of starters, and maintenance free operations is possible. But limitation is that it is suitable for normal data connected motors, and the factor by which voltage changes is 1 by root c, which cannot be changed. So it is used for machine tools, pumps, and motor generators, etc. This is the actually starter. This is the starter winding. This is the CFS supply, and this is the say start. Starting start and then running at the delta. Okay, so this is the triple pole double throw switch actually. Clear? So if we take into consideration the calculations of this type of starter, if we say the starting current IST per phase, so this will be 1 by root 3 times this IST should be equal to 1 by root 3 times the ISC per phase. So starting torque should be equal to starting current square, since at starting is equal to unity, and full load torque will be proportional to IFL square by SF. So if you take the ratio of these two, the starting torque by full load torque, so you will find so IST by IFL square into S. But this IST equal to this is 1 by root 3 times this. So you can write the ISC by root 3 IFL whole square into SF, that is equal to 1/3 ISC square by IFL into this full load slave. So which we say the star delta switch is equivalent to auto transformer ratio 1 by root 3 or 58% approximately. So that's all about this star delta starter. So once again we can repeat this. So this is the cheapest starter of all, and hence used very commonly for the induction motors. It is uses a triple pole double throw switch. The switch connects the starter winding in start at starting, and hence per phase voltage gets reduced by the factor 1 by root 3. Due to this reduced voltage, the starting current is limited. When the switch is thrown on the other side, that is, the winding gets connected in delta across the supply. So it gets normal voltage, and the windings are connected in delta when the motor gathers sufficient speed. And the arrangement of starter is shown here. Okay, and this actually operation of the switch can be automatic by using relays which ensure that motor will not start with switch in the run positions. And the advantage of this type of starter is it is cheapest of all, and maintenance-free operations is possible. But the limitation is it is suitable for normal delta connected motors, and the factor by which the voltage changes is 1 by root 3, which cannot be changed actually. So it is used for machine tools, pumps, and motor generators sets. So this is the schematic diagram of the starter. This is at start position, that is at starting, and this is delta at the running condition. This is the starter, and this is the result, and this is the squirrel cage rotor. So the calculations of this type of say starter will give you that starting current at per phase will be 1 by root 3 times the ISC, that's the short circuit current per phase, and the starting torque is directly proportional to the starting current square. Since at starting slip equal to 1, and full load torque is proportional to full load current square divided by full load slip. And so if you take the ratio of this starting torque and the full load torque, you will ultimately find this is IST by IF whole square into SF. So if you put the value of IST here, that is equal to 1 by root 3 times IS, so it will be IS by root 3 IF whole square into SF. Therefore, it is 1/3 of ISC by IF whole square into SF. Okay, so start delta switch is equivalent to an auto transformer of ratio 1 by root 3 or 58% approximately. So that's all about the different starter for squirrel cage induction motor. Okay, so basically we have discussed started our discussion in the last class, that is dual starters, and now in this class we have discussed the say discussions of primary resistor starter, then its simplicity, but its my power loss is more, but its cost is less. So in that case, we have used auto transformer starter to reduce this power loss by using auto transformer. But it is cost is more, and we can use at any percentage of tappings to reduce the starting voltage. But though it is a very useful one, but it is not cheapest. It is very say costly one, rather than the primary resistance starter. And we can use the reduced voltage up to say 58%, or by adjusting the values of X, that's the tapping positions, we can say invest different reduced voltage for the starting. And when the speed is around 80% of normal speed, so changeover can be happened, so that the full voltage is impressed across the starting winding. So that's why, and automatically this changeover is used by using relays, so that it cannot. It also ensure that, so when the say auto transformer say thrown over switch is at the run position, so it will not start. So basically, this is a protection, as well as that's why the cost is also high. and the cheapest one is the star delta starters we have discussed. And with this we can conclude our discussion on